Well, I will start discussing about subnetting in details. To understand subnetting, let me tell you that the entire IP addressing is classified into two types. One is called classful addressing, and another one is called classless IP addressing, which is CIDR, the concept of CIDR, VLSM, and all. Now, when we start talking about classful addressing, we have seen there are five classes: class A, class B, class C, class D, class E. And when we have seen the subnet mask, what is subnet mask? Subnet mask is, it identifies the network portion and host portion. Since in class A it is 8-bit is in host, 8-bit is in network, and remaining 24-bit in host. In class B it is 16 plus 16, and class C, class D and E is not required here because this is for multicasting and future use. Now in class C it is 24-bit and 8-bit. Now it is very much rigid. Class A, when I design a class A address, I need to take a range of, or I need to take a host of 2 to the power 24 minus 2, a block size of 2 to the power 24. And why I should take a host, or a host bit of 24 and host bit of 16 and host bit of 8 always. Okay, so in case of classful addressing, the subnet mask is fixed. It is called fixed length subnet mask. So in class C it is 255.0.0.0. Class B it is 255.255.0.0, and it is class C 255.255.255.0. So how many bits are there in network? All bits set to 1, and the bits which are in host set to 0. And that is how we calculate. Now in a classful addressing, that rigidity is there. What is the rigidity? That you should have it, you should take a block size of 24 in case of class A, you should take a block size of 16 in case of class B, and you should take a block size of 8 in case of class C. Now there is a little one more little constraint there in selecting IP addressing, that in IP addresses the block size should be in order of 2 to the power n, means it has to be 2 to the power, here in this case when it is class C, it has to be 2 to the power 8. In case of class B it has to be 2 to the power 16. In class of A it is 2 to the power 24. This is number of host, this is number of or I will not say number of block, it is block size, I will say it is block size, and number will be 2 to the power n minus 2. So it has to be 2 to the power number of host, it will be 2 to the power 8 minus 2 to the power 16 minus 2 to the power 2 to the power 16 minus 2 to the power 24 minus 2. So that is the major problem, that why should I go for a fixed length. I may require a block size of 2 to the power 4. So for that, there is a concept of classless IP addressing. The classless IP addressing, there is a concept of CIDR and VLSM, that's classful interdomain routing, the full form of CIDR, and VLSM is variable length subnet mask. So the variable length subnet mask is actually telling me how to calculate a variable size host, but it has to be there are a few golden rules and formula. Let me tell you the formula. Whenever we calculate, we have to take a block size which is 2 to the power n. So n, which is number of host, has to be maximum of 2 to the power n minus 2, where n equal to host bit. So 32 minus n is network bit. That means I can go for any number of hosts. So n can be 4. So if I take n equal to 4, so 2 to the power 4 minus 2, so I will be taking a 40 number of hosts. So 32 minus 4, that is 28 bit. 28 bit is my network bit. Okay, so I have to calculate subnet mask accordingly. Okay, so if it was 24 bit, the subnet mask was 255.255.255.0. So how to calculate a variable length subnet mask VLSM when this is 28 bit? I am giving you a table which will help you to calculate subnet mask VLSM quite easily. Okay, let me tell you where from I have derived this particular table. Then you can understand it better, that how to calculate the same. Okay, so here in this case, this is the number of hosts what I was talking about. So let's understand, or let's get a clear view about the entire 8-bit. Okay, the first value of the first bit is 128, next bit is 64, then it is 32, then it is 16, then it is 8, then it is 4, then it is 2, then it is 1. So that is how the entire 8-bit is. So the rule says if I have 28 bit, if I have, for example, 24 bit in network and remaining 8 bit in host, so this entire 24 bit network bit will be 1 and host bit will be 0. So there is a table to calculate it. Okay, so I have derived from here. Okay, 128, 64, 32, 16, 84, 4. Okay, so if first bit set to 1 and remaining all bit set to 0, the value is 128. So that means 1 bit means 128. So if it is 2 bit, then what will be the value? Then it will be 128 plus 64. So in that similar fashion, in this particular fashion, I have devised a mechanism by which you can calculate it very easily. Okay, so for example, I'm giving you a table. For example, if it is 28 bit, okay, the host is if it is 28 bit, how to calculate? Okay, so you have to take in the 28 bit, okay, you have to split it in 4 blocks. That means if it is 28 bit, that means it is 8 plus 8 plus 8 plus 8 plus 4. So this block 8 bit set to 1, 8 bit set to 1, 8 bit set to 1, and 4 bit set to 1. Remaining 4 bit has to be 0. So first bit, if it is set to 1, it is 128. Second bit, it is 192. Third bit, it is 224. If it is fourth bit, it has to be 240. If it is fifth bit, it has to be 248. 6, 252. 7, 254. 8, 255. So then I can find out this has to be 255.255.255.240. Okay, so there is a magic number. 256 minus 240 is actually 16. That is the block size, number of hosts. Now already you have seen, if it is 28, so 28 plus 4 is 32. So total is 32. So if this is host, sorry, this is network block, this is then host block. So host block 2 to the power 4 is nothing but my 16, so I get a magic number. Okay, so 256 minus 240 is 16, so that is a block size. So that is how we can calculate. Let me take one more example and elaborately tell you that. Okay, now how to write in CIDR notation. Always we, in case of CIDR notation, we mention how many bit set to 1, that means how many bits are there in network. For example, if I write slash 19, okay, that means 19 bit is in network, 32 minus 19, that is 13 bit is in host. So how many, n equal to maximum size will be 2 to the power 13 minus 2. Okay, if it is 2 to the power 13 minus 2, then I can calculate how many, what is the size of n. This is my block size, 2 to the power 13. Now 19 I have to split in this way. 8 plus 8 6, 16 plus 3 19 plus 0. So that means subnet mask will be 255.255.3 means 224.0. okay, so there is a I was showing a class C address previously. Now there is an easy way to calculate 256 minus 224, that means it is 32. So it has to be block size of 32 in this particular block, and it has to be, so it will be 2 to the power 8 plus 2 to the power 5. So 2 to the power 13 we can write 2 to the power 5 2 to the power 5 dot 2 to the power 8. So 5 plus 8 equal to 13. So 2 to the power 5 here and 2 to the power 8 here. So 2 to the power 5 means 32, that is a block size. So 32 into 256. So 2 to the power 8 is nothing but my 256. So that is how it is calculated. Okay. So next class we will discuss much more into details how we can do subnetting. For example, if I write 192.168.1.0/24, this is a clear case of classful addressing. If I have this kind of addressing, I can write today I'm going to demonstrate subnetting concept with a case. For example, ABC is an organization which is having three different offices. One is in north, this particular region is north region, and this particular region is east region, and this particular region is west region, and they have given a class B IP address 172.16.0.0/16. This particular class B IP address you need to do subnetting. Now they have given few specification. First they are telling that this 172.16.0.0, this is the entire network of this organization. This will be subnetted as follows. The subnetting, initially this has to be equally, this number of hosts need to be equally divided into three zones, that is north, south and east. North, east and west. Okay, now each and every region, after if you check that each and every region, north region is having 4 LAN. This is LAN 1, LAN 2, LAN 3, LAN 4, and then there will be another requirement that you have to further subnetting this particular IP addresses into 4 more subnets. So there are a few golden rules. For example, if I take 172.16.0.0, this particular network, this is class B network. So if I see class B network, the default subnet mask is 255.255.0.0, because the reason is, the rule says how many bits are there in network. The network bits all set to 1 and host bit all set to 0. So here the network bit is 16 bit and equal, host bit also is 16 bit. So since first 16 bit is set to 1, this is 255.255.255.255.0.0. So we need to concentrate on this 16 bit, because we have to actually do subnetting depending on this particular 16 bit. If I see the CIDR notation, I write this as /16. That means the first 16 bit is fixed, means you don't have to think about first 16 bit. Later 16 bit you have to work out. Now first I have to create 3 subnets. We cannot create because it is all 2 to the power. So here in this case, if I look into this 3 networks, I have to create 3 subnets. So I cannot create 2 to the power 2 equal to 4. I have to create 4 subnets. So if I want to create 4 subnets, I have to borrow 2 bits. That's the rule. I have to borrow 2 bits. Okay. So this is 16 bit. This is network. So from this particular host bit 16 bit, I have to borrow 2 bit. So that means it has to be /18. So all those subnets in this 3 region, okay, so this will be /18, this will be /18, and this will be /18 as well. How to calculate? What do I mean by /18? From /16 to /18, what do I mean by that? Okay, let's calculate. So /16 means 16 bit will be set to 0, set to 1. Now /18 means 18 bit will set to 1. So this is my subnet mask. Now here in this case I will be getting a different subnet mask, that is called VLSM. So I'm giving you a VLSM calculator so that you can actually easily calculate VLSM, variable and subnet mask. Please go through this particular. Okay, if you look into the IP addressing, I have the entire 32-bit block divided into 4 8-bit blocks. Okay, so if you look into the 4 8-bit block, this is 8-bit, this is 8-bit, this is 8-bit, this is 8-bit. So if all 8 bits set to 0, for example /16 means 8-bit set to 1, 8-bit set to 1, and this 8-bit set to 0, this 8-bit set to 0. So 8-bit set to 1 means it will be 255, and 8-bit set to 0 means it is 0. If in between, then I have to calculate. Means if it is 0, then the value will be 0. If it is 1, then it will be 128. I am giving you the calculator. How I am getting it? Because if you look into this particular table, I am just showing you the table. If you look into this particular, okay, bitwise value, this is 2 to the power 0, this is 2 to the power 1, this is 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7. So 2 to the power 7 means 128. This will be 64. So if one bit is set to 1 and remaining all bit are 0, so it will be 128. So in that way, if it is 1 1 and remaining all bit 0, 128 plus 64, it will be 192. So it will be 192. 3 means it will be 224. If you add 32 more, it will be 240. Then 5 bit, this has to be 248. If it is 6 bit, it has to be 252. If it is 7 bit, it has to be 254. If it is 8 bit, it has to be 255. Now from this calculator, if I calculate what will be 18 bit, then it will be, you have to take 8 bit maximum. Okay, 8 bit, then 8 bit, then 2 bit, 16 plus 2 bit, then 0. Now you can see the VLSM will be 255 255. 2 means 192 and 0 means 0. So it has to be 255 255 192.0. So let me show you another calculation, the block size. So what is block size? For example, if it is 2 to the power 8, the entire 8-bit block, there can be 256 numbers, which will be 0 to 255. So now here in this case, okay, if it is 192, so in that particular block, how many numbers will be there? It is very easy. 256 minus 192, it has to be 64. Okay, so another way, when we calculate subnets, okay, it is very easy to calculate the subnets. Now I have to calculate the subnets. So if it is /18, from /16 to /18, I have borrowed 2 bits. So I will be getting 4 networks. I will be getting, okay, the subnetting is, I have to get different subnetworks. So this was a network which will be divided into, I require 3 subnetworks, but I have to calculate 4 subnetworks. So I will be getting 4 subnetworks. So I am calculating 4 subnets. To calculate subnets, I have to okay, consider this particular network. So in this particular network, I will be getting 4 subnets of /18. So these are, I will show you how I am getting it. These are 0.0, 64.0, 128.0 and 196.0. Now please understand how I am getting it. Okay, so it was 172.16, forget about this, 0.0. Now if you look into the 8-bit, okay, the first 2 bit will be now in network portion. So this 2 bit, if it is varying, okay, what are the numbers I can get? 0 0 1 0, sorry, 0 0 0 1 1 0 1 1. If it is 0 0, then it has to be 0.0. If it is 0.1, that means this value is 0, this value is 64, remaining all are 0. So it has to be 64.0. If it is 1 0, then what will be the value? It has to be, this bit is 128 and remaining all are 0. So it will be 128.0. and if it is 1 1, say, so it will be 192. And you can see the magic number 192, that is subnet, when I was calculating VLSM, variable length subnet mask, in VLSM variable length subnet mask, I was getting the value as 255.255.192.0. this 192 I was getting by setting 2 bit 1 and remaining all 1 2 3 4 5 6 bit 0. So this value is 192. Here in this case also you can see, when I am getting 0 1 0 0 1 0 1 1, this 4 subnets, in case of this 4 subnets, the values will be multiple of 64. That is what I was calculating block size. So how many subnets? I have borrowed 2 bits, so 2 to the power 2 equal to 4. I am showing you the magic number, so it will be 0 1 2 3. So multiply 64, the block size, into 64 into 0, it is 0. 64 into 1, it is 64. 64 into 2, it is 128. 64 into 3, it is 192. And that is how I got 4 subnets. Okay, 0.0, 64.0, 128.0, 196.0. Now these are my different zone. If I look into this zone, this is not zone, so any number you can take. Okay, so here in this case you will be getting 4 different zone. Now you have to choose what are the IP addresses, what are the subnets you will be using. So for example, I am using slash 0.0 slash 18 here in this case. So this subnets I can consider this particular subnet here. So in the last segment we have seen creating subnetwork from given subnetwork. So 192.168.20.0 it was given, so I'm just changing the address 0.0. Let's see, we have to create 6 subnetworks. To create 6 subnetworks we have to consider 8, because it will be in the form of 2 to the power n or 2 to the power p. So it's 8 subnetworks. To design 8 subnetworks, we have seen that we have to borrow 3 bits. Initially we have 24 bit is there in the network and 8 bit is there in the host. Now it is 24 plus 3, and we have to have a block size of 32 in each subnetworks, and we'll be having 30 hosts. 30 host means 1 for gateway, 29 for PC. So that's how you have to manage. So let's first calculate the network address and variable and subnet mask for each and every subnetwork. So this we have calculated. This is the first subnetwork. This is the first subnetwork. This is second subnetwork, third subnetwork, fourth subnetwork, fifth subnetwork, sixth subnetwork, seventh subnetwork, and eighth subnetwork. So this is how from this calculation table we have designed this. So we have 8 subnetworks we have calculated. So the specification of all the 8 subnetworks are like this. A specification of all subnetworks, we have calculated. So now let us do few Microsoft Summary. So this is one activity is given, 10.148.100.54. So 10.148.100 148.100.54, and the subnet mask is given. Subnet mask is given as 255.255.240, 255.255.240. So this is you have to calculate. So initially, if we see this was there in the network. this was there in the network, and these all are host bit. So it was /8. So let's understand what do we mean by what do we mean by 240. So let's calculate from a magic number. 256 minus 240 is 16. That means it is block size of 16. So number of hosts in this network, number of hosts will be there in this network. That means number of valid IP address in this network, 16 minus 2, 14. So 4 bit. So initially it was 8. Now it is not 8. Now it is, let's calculate. Now it is 32 minus 4, that is 28. So now it is 28. So initially it was 8. Initially it was 8. Now it is 28. So how many bits you have borrowed? You have borrowed 20 bits. So you can create how many subnetworks? You can create 2 to the power 20, that many subnetworks. So just open up a calculator and show you, what is 2 to the power 20. 2, and just let's calculate 2 to the power 20. 2 to the power 20 is 1048576. 1048576. So that many subnetworks we can create. So how the subnetworks look like? Let's take 10.0.0.0. This is first subnetwork. 10.0.0.16. 10.0.0.32. like that. This will be varying from 0 to 10. So 16 into 0, 16 into 1, 16 into 2, till 16 into 1048575. So actually it's not like that. Whenever it is 16 into 32, like that, if it is 16 into, now when it is 10.0.0.240, next it will be not 10.0.0.256, because the maximum is 255. So 10.0.0.256 means 10.1.1.0 means whenever, if you add 240 plus 16, it is 256, means 255 plus 1 means 0.255, then 1.0. So that is how you are getting. So let's go to very near to this network, that is this particular series 148.100.0. then 10. These are the subnetworks in this particular series. 100, 10.146.100.16, 10.148.100.32. Now after 100.32 it will be 100.48. Now after that it will be 100.64. like this, that it will be going. So then 10.148.100.250 248, after some you know, some calculations of the network. So after this 148.100, it will be 101.0. so like that there is a change in the networks. So you can see this particular number 54 is residing in between these two networks. This two network. So this will be your network address. So this will be your network address. Sorry, this will be your network address. So you can see the next is 64, so 63 will be your broadcast address of this particular subnetwork if I am talking of. So this is, now I am talking of a subnetwork which this particular IP belongs to. So this will be 48 to 62. So 48 is nothing but my network address, 63 is nothing but my broadcast address, and let's get few more calculation. 49 is my first valid IP and 62 is my last valid IP in this subnet. So you can see this specification, this 54 is in between, so this is a valid IP. Since /28, this is my IP in this range, this is my subnet mask in this range. So this is my VLSM, we can say VLSM is this, and this is the subnetwork address, this is broadcast address, this is first IP, we can write first IP in this subnetwork, and we can write this is last IP in this subnetwork. So that's how we create, we calculate different subnetworks. So this is initial network address, and after that we are creating setting 192 as a subnet mask, and we create different subnetworks. So now this is the next one, given a diagram of multi-layered network address range and all those things you have to calculate. So this is the second one, it is given 183.26.103.20.215./1330. So let's calculate this 183. Now next we are calculating very fast. I am calculating this 183.26 103.26.103.215/30. Means it is 255.255.255.252. You do the calculation. Now next, this will be 256 minus 254, 252 is 4. So multiple of 4. So multiple of 4 is 212, and it is in between 212 and 216. Okay. So let's understand what is this one. Okay. So 212 is actual network address. This is VLSM. So 212 is network address. Okay. So this is nothing but the given address is nothing but my broadcast address. 215 is broadcast address, and in this range I am having two valid address. So this is not a valid address. I get only two valid address, that is 213 and okay. So this is not a valid address. So that's how we calculate. We have different ways of calculating different subnetworks. This is how we create 2 subnetworks, 3 subnetworks, 6 subnetwork. So dividing into writes different sizes. So next we'll discuss about a specific problem, how to calculate. Now this we have done. Now this will done. I will be doing in the next step. So this is the designing we'll be doing in the next step. So thank you. Meet you in the next step. Now we'll be discussing about calculating the address. So here some topology is given, and let's try to find out how we can calculate the address in terms of creating subnetworks from a bigger networks, calculating equal length subnetworks and subnetworks of subnetworks. So here in this picture you can see initially the requirement of 192.168.20.0 is a bigger network, and I am creating 8 subnetworks. So how I am creating 8 subnetworks? Let's do the calculation. So initially it is given 192.168.20.0. This is a class C network. So in class C network, the one rule is whenever you playing with creating subnetworks, so make a network address fixed, means this first 3 octet 192.168.20 should not touch this. So if I look into the CIDR notation of it, it is /24. Clear? Now if it is /24 initially, then this was my subnet mask initially. Now what I have to do, I have to create 8 subnetworks. If I want to create 8 subnetworks, the formula is 2 to the power n equal to 8. That is, we have to borrow 3 bits from host. Now if I am borrowing 3 bits from host, then the network look like this. Now initially this was my network, but I will be adding 3 more bit into 8. I will be adding 3 more bit into 8 and getting 27. So if I am adding 3 more bit into 8, this is still 20 dot. So if I am adding 3 more bit into 8, so I will be getting all possible combination of this 3 bit, and I can create the subnetwork. So what will be the all possible combination? 0 0 0. This is I am talking about first 3 bit. 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1. So let's go to the calculator. So this is a calculator in a Excel file. So let's start calculating it. So I will be calculating, just setting this after 192.168.20, setting this first 3 bit once as 0 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. So let's start calculating this. So this is 192 dot 168 dot 20 dot. Now I'm playing with first 3 bit. This first 3 bit set to 0 means I am getting first subnetwork. So I'm just changing the color of it. This first 3 bit, if it is 0, then, and what I am getting is subnet mask as till this 8 bit, 8 bit, 8 bit, and first 3 bit will set to 1, because in case of subnet mask the rule is whatever will be there in network, that means network bit will all set to 1 and remaining host bit will all set to 0. So in all 8 subnetworks this will be my subnet mask, and now I am calculating the network address. So the first network address is, so let's start calculating it. So in this case the first network address will be 192.168.20.0. Now simple, if it is 001, what it will be. Now we already got the calculation of VLSM, variable length subnet mask, which is 255.255.224. So this we have already calculated. Now this is 001. So if it is 001, then what I am getting? I am getting 192.168.20.32. So I am getting 192.168.20.32. So there is a very easy calculation to do it. Since this bit is varying, the block size is of 256. So what I am doing, I am when I am creating this 256 from 256, I am creating all 32 blocks, all 32 numbers blocks, then it will be all multiple of 32. So you can see this is coming in this particular fashion: 32 into 0, 32 into 1, okay, 32 into 2, so this will be 64, 32 into 2, then 32 into 3, into 4 equal to 128, then 32 into 5, it is 160, 32 into 5, then 32 into 6, 196. You can see if I add 32 to previous network address, 0 plus 32, I am getting next subnetwork address. Sorry, this is 64, 96, 128, 160, 190, and last but not least, it will be 224. So how many subnetworks I had? I had 8 subnetworks, so I have to multiply 32 into 0, 32 into 1, like last is 32 into 7, which is nothing but my 254. So the block size is 256 minus 224, that is a block size I am getting. And there is another way of calculating the block size also, that's if I am borrowing 3 bits the formula of number of hosts is 2 to the power n minus 2, because why minus 2? So let's create, this n is different, so I am writing b means borrowed bit, and 2 to the power n minus 2. So this 2 to the power n will be, in this case, here in this case will be 2 to the power n will be 32. Okay, so this is my calculation in this case. So let's vary all the bits, 0 0 1, then 0 1 0, then 0 1 1, 1 0 0, 1 0 1, 1 1 0, then 1 1 1. These are the 8 subnetworks I am getting out of it. So that is the calculation. Now coming back to the previous slide, where I was, that's calculating of subnetworks. When I was calculating the subnetworks in this particular slide, you can see I got all the subnetworks and all will be /27. Why it will be all /27? Because you had 24, now we are borrowing 3 bits, so it's all /27. So this you can write, this is /27, remaining all will be /27. So this is how we are creating the subnetworks. So if you are picking up any subnetworks, then you will be able to calculate all those in terms of network address, broadcast address. So let's pick this particular subnetwork and start calculating it. So in this particular subnetwork, this is a network address. What will be the broadcast address? Next network is 32, so the broadcast address will be 31. So it will start from 1, it will be till 30. So this is my first subnetwork. This is the specification of first subnetwork, that is 192.168.20.0 is a network address. 192.168.20.1 is first IP. 20.30 is actually, let's write it, network address, network address. This is first valid IP. Last valid IP. Broadcast address. So this is first subnetwork. So let's create the second one. Second subnetwork will be starting from 32. It will be 33. It will the next network is actually 64. So this will continue till 63, and the last. This is the specification. This is the specification of the network. This is my network address. Next subnet. This is first subnet. This is second subnet. This is 32. And /27 means all will be having this particular subnet mask, VLSM. This will be your VLSM. So this is your first subnetwork. This is the specification of first subnetwork. Specification of second subnetwork. Quickly let's do the other specification. The next one will start from 64. It will go till 95. Let's verify. Yeah, 95. 65 will be first valid IP and 94 will be last valid IP. So it will, the next one will varying from 96 to 127. 96 to 127. So let's calculate. This will be varying from 96 and this will be 97 till 127. This is 126. So I'm getting the specification of next subnetwork. So I've calculated first subnetwork, second subnetwork, third subnetwork, fourth subnetwork. Now we have to calculate 4 more. So let's quickly calculate. So after 96, this is your subnetwork. 128, 160. So this will be 160. This will be 196. So don't confuse, I'm just copying and pasting it here. This is 196 and last is 224. So let's quickly calculate them. After this is 96, so it is 128. So first is 129. This is 159. In all the calculation, I am not touching upon the first 24 bit. Okay, because whatever initially in class C network, so initial network address will be fixed. So this is how I am calculating all. This is how I am calculating network address, first IP, last valid IP, broadcast address. Now 160, so 161 will be first valid IP. So this is 2223. So last valid IP will be 222 and this is 197, and here in this case it will be till to 255. So this is 254, this is 225. Initially when there was a calculation, people used to say that we should not take this first network and we should not take the last network. But the initial concept does not arrive. Means initially people used to say that for host calculation we are doing 2 to the power n minus 2. For subnetworks, creation of subnetworks 2 to the power n minus 2 means 2 to the power b minus 2 should to be applied here. But now the today's arena, people says we should use all the subnetworks. Means in network address we should not calculate all network bits set should not set to 0, all network bits should not set to 1, and that is how I am calculating. This is first subnetwork, second subnetwork, third subnetwork, fourth, fifth, sixth, seventh and eighth. All 8 subnetworks I got. Now here if you see, they are again doing subnetworks of subnetwork. Again that /27 is again subnetted. So this is called subnetting of subnetting. So this you can do. Here it is wrong. After 216 it will be 220. It is not 20. So there are some mistakes always there. So this is, you calculate different host. So here you can see this is the activity. This is being given. For example, 10.148.100.54 one host address is given and one subnet mask is given. So that is how your next exercise is to calculate the network address from the given host address and subnet mask from the given given host address. So you have to calculate these subnetworks first valid IP, last valid IP, whether this is a valid IP, this is a network address or broadcast address, and all those things. So thank you very much. So we'll go to the next segment. Yes, we are going to discuss about classful addressing. So classful addressing is basically, how we classify the entire 32-bit into different blocks. So we have already discussed there is something called host address, there is something called there is something called host portion, there is something called network portion in address, in a host IP address. So here we'll come and discuss that there are some golden rules. First, in network bits are the one which is unique. For example, there are first 8-bit first octet is there in is actually network bit. So if there are 1000 PC in a network, for each and every PC that first 8-bit need to be common. First 8-bit need to be same. So that's what network bit, and remaining host bit need to be varying. For example, if I am talking about last 8-bit that's last octet is actually host bit, and if it is varying, so what we can get is 2 to the power 8 number of host, not exactly 2 to the power 8, because the golden rule says all host bit cannot set to 0, all host bit cannot set to 1. If all host bit is actually set to 0, it's called network address, and when all host bits set to 1, it is actually called broadcast address. So barring these two numbers, these two addresses, will be getting IP address. So always, if I am having n number of host bit, the valid IP addresses will be 2 to the power n minus 2. So depending on that, we will be designing the network. So initially, how to identify how many bits are there in network, how many bits are there in host, we need to calculate subnet mask. Subnet mask is the one which is actually telling me how many bits are there in network, how many bits are there in host. For example, if I am having 16 bits there in network, 16 bits there in host, first 16 bit will set to 1 and remaining 16 bit will set to 0. That is how we calculate. Now the entire 32-bit block, 2 to the power 32-bit entire 2 to the power 32-bit number block is divided into 5 classes. Class A, class B, class C, class D, class E. So how to identify each and every class? We actually look into the first, we have to look into the first octet. So if we look into the first octet, we can actually identify, what is, which class it belongs to. So if it is class A, the first 8-bit will start with 0. The first bit of first 8-bit will be 0. So we will be getting a range of 1, 2 and 27. If it is class B, it will be 1, 0. We will be getting a, and remaining all this first 2 bit will be fixed 1, 0. So that is, first octet will be varying from 128 to 191. That is how we can actually get the numbers, different classes. So A will start from 1 to 127. If it is starting from 1 to 127 in first octet, it is class A. Class B 128 to 191. Class C, that's 110. That's class C. It's varying from 192 to 223. Then in class D, when we talk about class D, it is the pattern is 1110. That is 224 to 239. Then we are having class E, the remaining one, the first 4 bit of first octet is set to 1, then 240 to 255. Now class D is actually multicasting, so we will not use class D addressing. Class E used for some experimental and subnetting, subnet masking and some research purpose. So we will discuss that.
So what is the classification? In class A, first octet is network portion, remaining 24-bit is host. In class B, 16-bit host, 16-bit network. In class C, 24-bit is there in network and remaining 8-bit there in host. So we need to calculate default subnet mask, setting host bit to 0 and remaining network bit to 1 and vice versa. So we get default subnet mask for A 255 remaining all 0, for B 255 255 and 0.0, and class C last octet will be 0 and remaining all are 255. So that is how we can actually get different subnet mask of different classes. So number of possible networks and hosts are actually calculated. So this is the number of possible host and subnetworks are there. Number of possible host means you can see in class A 7 bits are varying, so 2 to the power 7, that's number of networks we can design. So fixing first 2 bit, we can see in class B 14 bits are varying, so 2 to the power 14, that many networks we can design, and 2 to the power 16 minus 2, that many hosts we can design in each and every network. And in class B we are having wide range of networks, that is first 3 bit is fixed, so 2 to the power 21 number of networks we can design, and we can have each and every network 2 to the power 8 minus 2, 254 number of hosts. So that is the one when we classify, we have something called reserved addresses. So this is what valid host addresses. So valid host addresses in that particular range, it is saying this is used for unicasting. Basically we'll discuss what is unicasting, broadcasting and multicasting. Class D is used for multicasting and class E is some experimental purpose. So that's the total range of host addresses. We can calculate multicast addresses. Now in this addressing scheme, something called reserved addresses. So we can see starting with 0 is again reserved address, starting with 110.27 in the first octet, reserved addresses. So other than reserved addresses and other than private addresses, we have something called public addresses. Public addresses are the one which we can sell. So we need to understand the concept of public and private addresses. So private addresses, each and every class A, class B, class C in a network, some range is reserved. You can see these ranges are reserved for private addresses. So that's we are discussing what is class A block. Class A block, these are the characteristics of class A block, these are the characteristics of class B and class C blocks. So class based system got some limitations, that's why we move to classless addressing. So classless addressing, we have something called CIDR notation, that's class full interdomain routing, that CIDR full form is. So CIDR notation is classless interdomain routing, and it's a classless notation. We'll now discuss about classless notation. So we'll discuss about also what is network address, what is broadcast address, and then unicasting, multicasting and all. So we will, before we go to this unicasting and broadcasting, we will show, we'll demonstrate how to calculate network host and broadcast addresses of each and every subnetting. So here we are just taking a pause and we'll move to addressing in the network. We'll start with IPv4, then slowly move to IPv6. So I will just touch upon IPv6. What is IPv6? So let's understand what is IPv4 first. To understand what is addressing, we need to first know why there is a requirement of addressing. So the requirement of addressing is basically each and every host in a network need to be identified uniquely. So that's why we give a logical addressing. So TCP/IP protocol suite model has a layer which is network layer or internet layer, and in OSI there is layer 3 which is responsible for doing a lot of network related activities, and IP addressing comes into this particular area, into this particular layer. So it's a layer 3 concept. IP addressing structure, let's understand. It's a 32-bit address, 32-bit binary address which is converted into decimal, dotted decimal rather. So that is the representation of IP address. In IPv4 address, we will be learning what is classful addressing, A, B, C, D, E, and classless addressing, how to manage using CIDR notation, what is CIDR all about, and what is VLSM. So we will be also discussing about the concept of subnet mask. So in internet protocol, we identify each and every host by something called IP address. So IPv4 is one of the addressing scheme. It's a 32-bit binary number. So this 32-bit binary number actually divided into 4 octets. So each and every octet is 8-bit. So each and every 8-bit, if you vary 8-bit numbers from setting all the 8-bit to 0 and all the 8-bit to 1, it is varying from 0 to 255. That is the 2 to the power 8 number, 2 to the power 8. That is the total numbers you have you get from this particular block. That's 0 to 255. So block of 256. So if you see, it's a binary number, 32-bit binary number. So that address space of IPv4 will be 2 to the power 32. That's 4294967 That is the total number of IP addresses available. But we cannot use all. We'll discuss later why we cannot use all. So this is a number 192.168.10.1. This is a IP address which is actually belongs to a network. In network 192.168.10.0. So what is network, what is IP address, all those things we'll discuss. So to understand the concept of IP addressing, we need to understand how to convert a 8-bit binary number to a decimal number, and a decimal number to be converted into a 8-bit binary number. So this is the table which is being given, and I have also shared one Excel file where you put any number in that entire 32-bit combination of 0 and 1. You will be calculating, you will be able to calculate subnet mask and as well as IP address of the network. So that's the conversion, 1110101. That's the binary number which is converted into a decimal number, which is 245. So we'll be discussing initially how to convert a binary number to decimal number to binary. So when we talk about addressing, we'll be talking about how we can actually divide it, how we can actually divide the address into two parts. One is network portion, one is host portion. So let's understand, the hierarchical structure of IPv4 addressing. It's a 32-bit number. So the entire 32-bit number has something called prefix, which is network portion, and the later part, which is host portion. For example, there are 30 PC in a network. There are 1000 PC in a network. All these 1000 PC, if they're in a logically in a same network, they should be having a same network. So how to identify they are in the same network? Because their network portion should be common. So any number of bits can be in network portion and any number of bits can be in host portion. That is the design part of it. So in this you can see it's a addressing which is 192.168.18.57. It's the first 3 octet is there in network and remaining is there in host. So the anatomy of IP address is actually, start with the concept of 32-bit address, which is there are 4 octets, and we need to understand the binary equivalent of each and every dotted decimal address. So in network layer, each and every host identified a 32-bit address. So for example, we are having host A, we are having host B. So host A is sending some packets to host B. So packets is actually, how network layer sends their communication. So host A will be having 32-bit source address and host B will be having a 32-bit destination address, and we'll be using a layer 3 header, which is nothing but IP header. So we are having IPv4 header as well as IPv6 header. We are discussing about IPv4 header. So let's understand what is network portion. Network portion is actually, identifying in a network, identifying which network it belongs to. If I look into a IP address 192.168.1.0, so some portions are there in network, some portions are there in host. So if all the PCs and all the hosts are there in same network, so their network portions need to be common for all the hosts, and the host bit need to be varying. So that's we'll be discussing, how to calculate number of hosts. So this is IP addressing structure, and this is a example how you can convert a 8-bit binary number to a decimal, and decimal number to a binary number, and binary number to a decimal number. This is already I have shared. So this is Excel file. Double click on this Excel file, then actually you can do a lot of calculations over here. So I will be sharing this particular PPT, and double click on this particular slide, and you can easily do a lot of calculation in terms of IP addressing. So this is how you can do a lot of binary to decimal conversion. Some examples are there for binary to decimal conversion. You need to practice that. So decimal to binary and binary to decimal conversion, you need to practice. So now next we will be discussing about classification of IP addressing. So classification of IP addressing we have already discussed. There are classful and classless addressing. We need to know what are they.
Okay, I'm going to give you the overview of IP addressing. Since a lot of students has doubt understanding IP addressing, let me start with the topic IP addressing. What is the basic of IP addressing? What is classful addressing, classless addressing? So to understand IP addressing, let's understand what is the primary job of IP addressing. Whenever we need to give IP addresses to any devices or any host, what we need to do is just go to the configuration of the devices, and we give a IP address. Now why we need to give a IP address? Since these are the primary jobs given in the slide: delivering messages, network interface identification, routing. But the primary job is to identify a device. Primary job is to identify a device by its address. For example, I want to identify a particular person by a name. Sometimes if the person is a student, for example, you all guys are a student, so I need to identify sometimes by some enrollment number when I call your roll number. So I need to give some number, or here in this case also, when I'm giving IP address, I'm giving some number to identify a particular device. So why IP addressing? Why IP addresses? Now, even though since each and every hardware addresses having MAC addresses, hardware addresses, why I should give IP address? IP address is generally come from Internet Protocol. Now Internet Protocol is a layer 3 protocol. What is layer 3? Since all of you know that in a WSI model there are 7 layers. So now layer 1 is physical layer, layer 2 is data link layer, layer 3 is network layer, and similarly in TCP/IP protocol suite model we have internet networking layer. Now this layer generate a address which helps particular device to be identified in a network so that it can communicate. Now what is IP address? IP address generally when we use, it's a binary address, but it's a 32-bit binary address, but it is actually represented by dotted decimal notation. Now it's a 8-bit 8-bit octet. So for example, here in this case, if you see this particular address, if you convert this particular address to IP address, here in this case this is not IP address. So if you convert this particular address into IP address, you need to know how to convert a binary number to a decimal number. We will learn this. So generally this is a 32-bit binary address. So if it is a 32-bit binary address, we represent it with a dotted decimal. So we'll talk about subnet later. So IP addressing structure, for example, this is IP address 227.82.157.177. So if you pick up any 8-bit number, for example 0 1 1 0 1 1 and this 2 if it is 0, how to convert this particular binary number 8-bit 1 2 3 4 5 6 7 8, this particular 8-bit number into decimal number. This value is 2 to the power 0, nothing but 1. This is 2 to the power 1, 2, this is 4, this is 8, this is 16, this is 32, this is 64, and this is 128. So if you convert this, you add the corresponding numbers. So for example, 32 plus 16 plus 4 plus 2, that is 54, I think. So 32 plus 16 is 48, 52, 54. So this, if you convert this particular binary number into decimal, this is 54. And similarly, you can convert any decimal number into binary. So 177 is, it is very easy. Just first write what is the corresponding value of each and every bit. So you need to know the corresponding value of only 8 bits. So it is 1 2 4, it is 2 to the power 0 to 2 to the power 7. So 32-bit, basically this number has two portions. Okay, this entire 32-bit, this 32-bit is having 4 block. This is first block, this is second block, this is third block, and this is fourth block. Now this 4 block generally has this entire 4 block generally divided into 2 parts. And this, when we start learning about classful addressing, this is fixed, and when it is classless, it is not fixed. I will talk to that later. Now 32-bit internal structure of this particular IP addresses, this is having 2 portion, network portion and host portion. That is why it is written here, that is network identifier and host identifier. So here in this case, this is 8-bit network ID, 24-bit host ID, depending on the on different classes. So IP address scheme, what I was talking about, this is divided into 2 parts. One is classful address, one is classless IP address. So if we talk about IP addressing, we need to know 2 things. One is classful addressing and one is classless addressing. This subnetting and supernetting we'll discuss later. Now what is classful addressing and what is classless addressing? Now in classful addressing, what do we mean by class A, class B, class C, class D and class E, and how these are classified? Now I'm just going through this slide of Verizon, and let me tell you, give you an introduction of classful addressing. Now these are the address space. Now there are a few golden rules when we talk about IP addressing. The entire address space is 2 to the power n. Here n is 32-bit. Now this is called IPv4 addressing. We have 2 types of IP addressing. One is called IPv4, one is called IPv6 addressing. So my address space is 2 to the power 32. So I should have 2 to the power 32 numbers. So many numbers of IP address I should have. Okay. But this entire address space is divided into 5 categories or 5 classes when we talk about classful IP addressing. Okay. So skip this portion. When we talk about this entire classful addressing is divided into 5 different address spaces, A, B, C, D and E. These are called classful addressing. So what is the requirement of classful addressing? When I started talking about IP addressing. Now when I started talking about IP addressing, I already told you there are two things. One is network portion, and the first block is called network identification portion, and remaining is called host portion. Now I need to have one golden rule, is that for example these two hosts are talking with each other, or two devices are communicating with each other. Basic rule has their network portion need to be common. Okay, so their network ID need to be common, and their network portion need to be common. So if their network portions are common, then I need to fix the network bits. So for example, if I take the example of 192.168.1.1 and 192.168.1.2, here in this case you can see this entire portion is common. Okay, so for different classes, class A, class B, class C, class D, class E, okay, the different portions are common. So there is a different mechanism how we classify this. Okay, for example, when we have this 4-byte number, first byte, second byte, or 4-block number, this first 8-bit will help me to identify which class it belongs to. Now if it start with 0, that means this belongs to class A. So what do I mean by the number, the first block, the first bit is fixed, the first bit is fixed with 0? That means if you see the entire values of all the 8-bit, this first one is 1, the second one is 2, then 4, then 8, then 16, then 32, 64, and then 128. That means the number has to be less than 128. So that means it is in between 0 to 127. So I can actually identify that if my number belongs to class A, it is in between 0 to 127. Now if it is 10, that means I calculate in a different way. If it is 10, that means 128 plus 64 is 192. So it has to be less than 192. How? Means if it is 10, then remaining all bits are 1. Then this value will be 191. Okay, so this will be from 128, because this will be fixed 128 to 191. Okay, now similarly for in case of class C, it has to be the value will start from 192 to if it is 110, then it will be 110 means if I fix it to 110 and remaining all bits are 1, then it has to be 224. So it will be in between 192 to 223. Class D, then again 224 to 239, and this will be 240 to 255. Like that, by seeing the first 8-bit, I can classify. I can actually split that in this entire range of IP address space into 5 different classes. Now, what is the algorithm? How to check this entire or this particular IP address belongs to which class? So if first bit is 0, class A. If not, then it is 1. Then the second bit is 0, then it is class B. That's how the the network identifies which class it belongs to, and then they start communicating, and that is how they do the mapping. They compare two IP addresses. Now third bit, if it is 0, then it is class C. Like that, by identifying first few bits, we can identify which class it belongs to. Now class A, B class C used for commercial purpose. D and E are used for research and other activities. D is basically multicasting address, E is research activities. Now from this we can see that class A has 2 to the power 31 number of addresses. One bit is fixed, so it should have 2 to the power 31 addresses. Now I'm skipping this part. Now this is what we have calculated. The first bit, if it is 0 to 127, this is class A. 128 to 191, this is class B, class C, class D, class E. Now in case of class A, the first block is network portion and remaining 3 blocks are in host. So in case of class A, it is first and remaining 3 blocks are in host. In class B, it is balanced, 2 blocks in network and 2 blocks in host. When we discuss in details, we'll tell you later. This 3 blocks in class C and 1 block in class 1 block in host. So what do I mean by that? That means how many hosts is possible in class A. So 3 blocks means 28 bit. So how many blocks? How many numbers in a block? 2 to the power 24. Now there is a golden rule. All host bit cannot set to 0, that is called network address, and all host bit cannot set to 1, that is called broadcast address. And that is why we miss 2 addresses always when we calculate IP addresses. So a single normal class A address is class full address should have 2 to the power 24 minus 2 number of hosts. In class B, it has to be 2 to the power 16 minus 2. In class C, it has to be 2 to the power 8 minus 2. Now that is what I was talking about. Class A, this first 8 bit, then remaining 24 bit. In class B, it is 16 bit. Class C, it is 24 bit, 8 bit. So in a network, how many number of hosts are possible? This is what it is calculated. And D and E is multicast and reserved for future use and other purposes. So how we actually identify each and every block, that we'll talk later. So this is my blocks, calculation of blocks. So in the next segment, we are going to discuss about classful and classless IP addressing. Segment, we will be discussing about how to design a topology using IP addressing, subnetting and all. So here you need to design this following topology given by this network. This is the original class C network, 192.168.0.0 network, and here the requirement is that the connectivity among these routers are as given in the picture, and R1 should be connected with LAN 1, which require 50 PC, R2 in LAN 2, which require 30 PC, R3 in LAN 3, which require 10 PCs, R4 in LAN 4, which require 20 PC, and R5 in LAN 5, which require 6 PCs. Now let's understand that how we create this subnetting, how we go for further subnetting of subnetwork and all those things. So with this example, let's understand this. So Here I am giving a specification that R1 required the requirement of R1 is R1 need to be connected with 50 PC. So the requirement is 50 PC should have 50 IP. Now there is something called the concept of gateway. What is gateway? Gateway is by which the PCs in the LAN 1 will be connected to other networks. So that's nothing but the IP given to the router. So one IP should be allotted to the router. So the requirement is now 51 host. So that's whenever we are collecting number of IPs, we have to collect the number of PCs as well as number of gateways. So 51 host. Now we will be using this particular formula, 2 to the power n, which is greater than equal to 50. So that 2 to the power n, okay, the power of n is actually block size. So 2 to the power n we have to calculate. So 2 to the power when 2 power of power will be 6, 2 to the power of 6, power of 6 this results me 64. So if 2 to the power n greater than equal to 51, it has to be 64. It cannot be less. If it is 32, then we cannot take. So here in this case I have to calculate the block size. So here in this case the block size is actually 64. Now initially I have been given a network 192.168.0.0. so here when the block size is 64, that means that's 2 to the power 6. That means here I have to calculate, I have calculated host bit as 6. When I have calculated host bit as 6, so my network bit will be 32 minus 6 is 26. This is my calculation of network bit. Now here in this case we have seen host bit is 6, so network bit is 26. So initially it was /24, now it becomes /26. So when it becomes /26, we can create how many subnetworks? Because in that 8-bit block, 6-bit is now in host bit, so 2-bit we have borrowed. So since we have borrowed 2-bit, 2 to the power 2 is 4, so 4 number of subnetworks we can create. So let's understand what are those. So 172. So to do this calculation, let me go to a calculator and do the same. So for example, this is my calculator. Here I am taking all this bitwise calculation. This is, for example, network 192. 168.0.0. now here this 2 bit I have borrowed, so this 2 bit since I have borrowed, so I will be getting all possible combination of these two, that is 192.168.0.0. so next possible combination is 0.1, that is 64, 1.0, 128 and 0.1. So 1.1, that is 192. So how many subnetworks I can create? 192 dot, from this if I am borrowing 2 bit, okay, after borrowing 2 bits I can create 4 subnetworks. This is the first one. Now next is 64, next is 128, and last one is 192. so here in all those cases, the subnet mask will be 255.255.255.192. Why this will be subnet mask? Because this is because my host bit is 6, so 26 it actually now network bit. So calculating network bit, this 26 bit, so this in this calculation this all bit will be 1, and here it is all bit will be 0. So that is how we calculate the subnet mask. So in these 4 subnetworks I will be only taking the first subnetworks. So let's get the specification. This will be my network address, this will be my network address, this will be my broadcast address, and excluding this two I will be getting, this is my first IP, first valid IP I am getting, and this is my last IP. So this is my first IP and this is my last IP. So that is what my calculation is. So now out of this 256 block I have used 0 to 63. So next block is this 192.168.0.24. Now I'm going for the calculation of the second router, that is in here the router 2 is connected with 30 PC. Now we have to give the priority as far as the size of the subnetwork. Now the size of the subnetwork, 50 PC means 51 host, then 30 PC means 31 host. Now here in this case there is a 30 PC, so it will be 31 host. Now if it is 31 host, then in this case the block size cannot be 32, because 32 minus 2 is 30 host, but here in this case I require 31 host. So here in this case block size will be 64. So since this is for router 2, since the block size is 34, so I have to go for the next subnetwork, which is 64. The first IP will be 65, that I will be always giving it to the router. Now last IP will be 126 because 127 is broadcast IP. So that is my subnet mask all about. Again, in this case the subnet mask will be the calculation, you know, it's 26 bits is there in the network, host bit is 6, so since network bit is 26, this is how we have calculated. Since network bit is 26, from host bit we have calculated. So initially from the requirement we have calculated, you know, since block size is 64, so we have calculated all those things as a host bit as 6 and network bit as 26, and in this case we have borrowed again the same way we need to go for borrowing all those things, borrowing the bits. So here you can see 64 is network address, 65 is first IP, 126 is last IP, 127 broadcast address. And this is my subnet mask, and subnet mask is calculating all 26 bit to 1 and host all bit to be 0. So that is how I have calculated. So going for the next one, that is now not router 3, going for the next one, that is router 4, because whenever we will be creating subnet we have to give priority to the bigger blocks. So let's go for R4. R4 is 20 PC, so 20 PC is 20 plus 1 21. Then here in this case we have to go for block size of 32. Host bit will be 5, so this will be 27. So here in this case what you can see, we have already used 0.0, 0.64. so this is my next subnetworks. So the concept is, when I have next subnetwork, so this subnetwork again I am going for, instead of /26 I am going for /27. that means one more bit I am borrowing. So when I am borrowing one more bit, that means this is the concept, you know, we go for subnetwork of subnetwork. Means initially we have 4 subnetworks. Here in this case, when I was actually taking the bigger blocks, I had a 4 subnetworks. When I had 4 subnetworks, I have used 2 subnetworks. Now from this third subnetworks, if I am borrowing one more bits, then I am actually creating from this /128, I am actually creating 2 more subnetworks. So let's understand how I am creating this 2 more subnetworks. From this calculator, you know, we can actually calculate. So here in this case I am borrowing one more bit. So since I am borrowing one more bit here, if this bit is fixed, so I am calculating, you know, 2 subnetworks, that is 100 and 101. Are you getting it? What is the concept? Initially this 2 bit was utilized. Now when this 1 bit is borrowed, so in this case this was the bigger network, so this bit I have borrowed. So 128 network is further subdivided, because this bit I can actually, this bit can set to 0, set to 1. So I will be getting 100 and 101. So 2 subnetworks I am getting. Okay. So in case of /27, actually I am going for 2 subnetworks. This will help you to calculate better. This is 2 subnetworks I have created. So this next subnetwork I will not use. The next subnetworks will be used for the next calculation. So this I have done. So this subnetworks I have /20 dots 28 /26. When I am borrowing one more bit, further subdivided. Okay. So since it is further subdivided, so That means this bigger subnetworks is again split into, after borrowing one more bit, further subdivided into 2 to the power 1, that is 2 subnetworks. So 2 subnetworks are .128/27 and .160.27. So that is how we can also calculate. So when I have calculated this, let's calculate this particular subnetwork in terms of calculating network address, in terms of calculating first IP, in terms of calculating broadcast address, and this will be all /27. So since this is all /27, I will be getting, this is how I will be calculating my subnet mask, because network bit is 27, host bit is 5, and sorry, this is 128, this will be 129, and this will be 158. So this is what my first IP, last IP, and all and all those things. Now next is 10 PC. So this I have created the third subnetwork. Now after creating the third subnetwork, I am going for router 3 10 PC, router 3 10 PC. Now router 3, when I am having 10 PC, I am having 11 hosts, so there will be block size of 16. Okay, when there is a block size of 16, so this is 4 bit. So since this is 4 bit, this is /28. So instead of using this one, I will be using /20. This is again subnetwork of subnetwork. So here in this case we can calculate, this is /28. So since /28, this will be till the next one will be 176/28. So again I am further subdividing and further subnetting I am doing. So /176 is the next one. So this is 175. The last IP will be 174. So this is 160 is the network, 161. So this is /28, this is /28, this is /28, this is also /28, and this will be 240. So this is my calculation. Block size of 16 in this case. For R3 I have calculated, this is my network address, this is my first IP, last IP, first IP to be given to the router, last IP 174, broadcast address 175. Then I am going for router 5. In router 5, when I am going for calculating router 5, it required 6 PC. So 6 PC plus 1, 7. So 7 plus 2, 9. So we have to go for this one, this particular subnetworks. So my here in this case my block size will be 16, so it will start from 76, and this 76 will go till 192. So till 192. So till 192, this is 176 till 191 it will be. So this is my subnetwork. So my first IP will be, this is my network address, my first IP, last IP, broadcast address, and this is my subnet mask. So next we have 1 2 3 1 2 3 4 5 6 different networks. So 6 different network will be all of size 4. So since host bit is, since there is in between router there is a connectivity of 4 to 2 IP, so I will be requiring block size of 4. So here in this case, if I am going for block size of 4, it will be /30. So from /192 I will be getting all 30 network. So here I am getting only two IP addresses, that is 192, first IP is 193, last IP is 194, broadcast address is 195. So this is /30. So I am calculating all those different sub networks in this case. So it is 30, it is host bit 2, so it is my block size 4, host bit 2, network bit 30. So this is my specification. 3 and 4, 2 IP I am getting. So this will be 252. Sorry, I've calculated. Okay, so this is my subnet mask. So this is one network. Next will be, after 192 add 4, 196. So next network will be 196, 197, 198, 199. So this is my next network. Next network will be again 200, 201, then 200, then next 201, then it will be 202, then it will be 203, like that. Next network will be 204, so it will be 204. First IP will be 205, 206 will be last IP, this is 207, next will be 208, like that. You have to go for the calculations. So many sub networks we can create now, and this is the calculations. We can create after 208, it will be 212, then it will be 216, 220, it will be continuing like that. So you have to keep on calculating all this. This is for 204, so then you have to calculate for 208 and all those things. So let's see how many sub networks I have created. 192 network, 196 network, 200, 204, 208, 212. So that's, I am allotting each and every IP to the router. So router 1, router 2, router 3, router 4, router 5, and I am making the connectivity as per as this specification, fast Ethernet and serial interface, and these are the IPs for different router interfaces. Okay, so these are the IPs. You can actually, depending on this calculation, you give the IP, then this is the configuration of router 1, this is the configuration of router 2, this is the configuration of router 3, router 4, and router 5, and like that we complete this particular topology. This is the practical part of it. So